chain rule applies to composite functions. And many people get confused when they see a function as to whether it's a composite function or it's the product of two functions. I'll try and explain the difference a little bit later. But composite functions are where you have y equals some function of g of x. And you may recall with previous work that that can be like if you can sometimes write it, the little circle here says composite. So that's the way to write it with brackets. So you've got a function of x, and then that becomes the input for another function. So that is a composite function. So if we said that if u is this function here, so u equals g of x, and y is equal to some function of u, so u is g of x, and instead of that g of x there, we can put u, so y is a function of u, then dy dx, and this is the chain rule, is equal to dy du. That means the derivative of y with respect to u times du dx. So that's the chain rule that needs to be committed to memory. That's if you've only got a two-level, you've got two-level composite. You can have three levels, so you can go f of g of h of x, and it would be just all chained together. You can see how in the chain rule, even though you can't do it, if you could, you've got dy dx on the left, if you could divide the du's out, and they would cancel out, you've got dy dx equals dy dx. So that's the way to remember it. Think of it as if you could do the du's are chained together. All right, so let's have a look at an example and see what's going on. If we had y, well, let's change our pen back to black there. If we've got y equals the square root of x to the 5 plus 1. Now that's an example of a composite function. If we go back to my original explanation with functions as like a mapping. So we've got an x, and my first function is to find the square root, raise it to the power of 5, and then add 1. So that's my first function. Get a value of x, raise it to the power of 5, and then add 1. That would map the point x onto 1 point. Then we would get that value as an input, so maybe it ends up there, and we would find the square root of whatever that is, and we would get another point here. So we've mapped point x to a point using to the power of 5 plus 1, and then we found the square root of that to get to there. So this can't be confused with a product going on. It's a function of a function. So my g of x, which is u, so we've got u equals x to the power of 5 plus 1. So that is my first function. So this is u of x, and then this is f of u. And this is the whole function here going from one to the other. So we've got y is equal to that, u is equal to that, and y equals f of u, and f of u is the square root of u. So that's my second function. So I can say that du dx, if u is equal to that, then du dx is equal to 5x to the fourth, derivative of the constant is 0. Now we've got to find dy du is equal to, now square root of u is u to the half, means the same thing as square root. So dy du is equal to half u to the minus a half. So I can quote the chain rule. Dy dx equals dy du times du dx. It's a matter of now going up and substituting in. Dy du is equal to half u to the minus a half times du dx is 5x to the fourth. Now we do a back substitution. What is u equal to? We go back up to here and we can see that u is equal to that. Now u to the minus a half is 1 over u to the positive a half. So it'll be 1 over, that 2 can go downstairs. U to the minus a half is u to the half down here. And that will be equal to x to the power of 5 plus 1 to the half times 5x to the fourth. Now, since the question did not have any powers that had fractions or decimals or whatever, and it used the radical sign, we should put a radical sign down here as well instead of to the power of a half. Multiply out, 5x to the fourth times 1 is just 5x to the power of 4 over 2. Now, to the power of a half means square root, x to the power of 5 plus 1. And there it is. Alright, so the chain rule applies to composite functions where you've got a function of another function. And this is the chain rule, so you've got to actually set up which is which, work from the inside out. So you go from this first and you let that equal u, and then y is equal to that one there. Work out what du dx is and what dy du is, quote the chain rule, substitute in, do a back substitution for u, and then express your answer as simply as possible.